I will be holding today's workshop called on the topic of handling missing data and outlier detection. So maybe we can first start by just a quick recap from the previous workshop. So in the previous workshop that was 2 weeks ago, we introduced Pandas, which is a popular, I would say, mainstream Python library for working with tabular datasets. So people that are doing data science today that are using Python, which is a most popular programming language for data science and machine learning today, usually use also Pandas library for working with datasets if they are in tabular form, so in tables. And most datasets come in that form. And Pandas is really easy to use, lightweight library that enable data loading, basic information, data, descriptive statistic, inferential statistics, data cleaning, data pre-processing, and so on. And last time we learned how to upload our datasets into Pandas data frame, how to inspect the data frames to see how many rows are there, how many columns are there. We also learn to derive some basic statistical measures such as median, average, minimum, maximum value, and so on. We also learn to introduce new columns into datasets, rename existing columns, then sort the values within each column or within rows by some condition. And the most important thing, and maybe most complex, was to learn how to filter and how to group and aggregate datasets. So the filtering part means that you can make a subset of your dataset by filtering the data based on some condition. So you can come up with some condition and say, I don't know, I only need days from Monday to Wednesday, or I need temperature higher than average temperature, or so on. Or the second technique that I also mentioned was grouping and aggregating. So you can group the rows if they have some identical value. For example, if there are multiple rows with the same day, or with the same date, or with the same, I don't know, temperature measurement, you can group the rest of the values for that common value, and then do some aggregation. For example, average or minimum value, maximum value, or something like that. So basic statistical measure. And then after you group and aggregate, you can make a new a new subset. I wouldn't say strictly subset, so maybe new grouped data set that tells you a new story about your data. So you can learn how is your data behaving on some new subsets on some new groups of data. Okay, that was the things that we learned about in the previous workshop. And today we continue with the Pandas library, but we will learn how to pre-process our data or clean our data if the data has some issues. And most of data in real world has some issues. And the issues in particular that we'll talk about today is missing data. So if we have some data set that doesn't have every cell filled, and also outliers. So outliers are also common, and we'll talk about it after this handling missing data. I shared my notebook and pasted in chat, so you can just click on the link and follow in your own tab on your own laptop, on workstation. You can use the same data from that notebook, but the notebook is also uploaded on the GitHub of the whole project, and I can also share the GitHub link. So just give me a moment. And okay, yeah, I also pasted here the GitHub link of this of the Jupyter notebook that we will use for today's workshop. We will also use one other Jupyter notebook, but after we pass through this, then I will share the second link. Okay, so you can either use this shared link in the first comment, or just download the whole notebook from the GitHub. The thing is with the notebook from the GitHub that it already contains filled cells, but I erased all the closed cells, just not the first two, and I erased all others, so I can type it during this workshop, so you can follow along and communicate with me, so we can make it more dynamic. Okay, if you maybe have some questions before we start, feel free to type it in the chat, and you can do it whenever. So if I'm talking about anything, something, and you have any question or some issue, feel free to type it in the chat, and I will see it and immediately respond. Okay. Okay, so we can start with first notebook. So the first part of today's workshop is handling missing data. So I can maybe first explain what is the missing data, although I already mentioned something before. So missing values, the word itself explains. It's self-explanatory, but what does it mean specifically in data science? So if you have some data set that you acquired either by doing your own measuring, or you download it from internet, or maybe colleague of yours from some other domain sent to you, and he or she wants you to look at the data set and do some data science. These data sets, as we discussed before, usually come in tabular form, so in form of a table, where rows represent instances of a problem and columns represent characteristics of those instances. For example, medical data sets, the rows would represent patients, and columns would represent characteristics of those patients. For example, blood pressure, sugar levels, and so on and so on. It is common for those datasets to have some missing values. So that specifically means that some cell doesn't contain any value. We can extend the definition by saying that not only that missing value is that there is no value, we can also say that there is no valid value. So for example, you expect some number and there is some letter, and that letter doesn't have any meaning, and it cannot be mapped to the number. For example, you expected blood pressure and you see a letter K, or a question mark, or I don't know, some other invalid value. It largely depends on the person who ran the experiment. For example, person who ran the experiment and derived some measures didn't acquire that particular value. For example, didn't measure the sugar level of some patient, and one person would decide to leave it blank, while another person would put the question mark there, or some other person would say there is no value or something like that. So all these instances are the part of the problem that we call missing value. So there is no valid value, and our job as data scientists is to find those values. So it's easiest to find the values that are not present, so empty cells, but also we have to find the values that are invalid, and we have to collectively call those values missing values. Okay, so another question that we need to ask ourselves after finding those values is why are the values missing? So it interconnects with the problem of recognizing the missing values, because we can say, the person didn't measure those values, or there is some error with the data set. It can be the missing values can happen for multiple reasons. Okay, and after we recognize those missing value, our job is to decide what to do with them, and we will learn some of the techniques of dealing with missing value today, using, of course, pandas in Python. Okay, so we will learn how to detect those missing value and do some removing or filling techniques. We can start by creating some small datasets just to have some exemplary datasets to start. And of course, we will first import pandas and NumPy as Python libraries that are needed for today's workshop. So I will just run the code cells that says import pandas, and as PD, as we talked as we discussed that in the previous workshop, and I also need to import NumPy because the NumPy is prerequisite for pandas. And I already have a code cell that defines our data. To save some time, I will just explain it here. So I have 4 columns that are called timestamp, temperature, humidity, and CO2. And I have some random values. So I have measurements on the same date, that is the 1st of June, from midnight to 7 in the morning. So I have 8 measurements. And I measure temperature, humidity, and CO2. And I have several measures for temperature, humidity, and CO2. You can see that after I defined this Python dictionary, that is one thing that we also discussed in the previous workshop. So we can define a Python dictionary within the code and just put it here. Put it here in data frame constructor to make a data frame. And if I print the data frame, I will see all the rows as present here. So just to maybe zoom it, you can see we have a data frame containing 8 rows and 4 columns. We can also see there are some unusual values that are abbreviated like this, NaN. So that means in Python specifically not a number. And why is here not a number? Because we put it purposely in the dictionary by calling from NumPy property none. So this is just short for not a number. So we can deliberately put it in a data frame, as I did for this workshop, and it will the printing of the data frame will show none abbreviation, so not a number. Not a number is actually the symbol in pandas for missing value, because pandas has a set of methods that we'll learn about in a couple of minutes that deal with those nuns. So if we are dealing with missing values, we are actually dealing with instances of not a number in our data frame. So if you have a not a number of short none in your data frame, you actually have a missing value. Why is there a missing value? Why is there not a number? In this case, we put it deliberately, but as I already discussed, it can happen for multiple reasons. For example, the person who ran the measurements didn't know what to put, so it put a blank. So in CSV file containing the dataset, there is no value. So for example, we can have 2 commas in a row. So that means that between the commas, there is no value. If I want to run it like here, Python gives me an error because it's invalid syntax. So I have to have some value here between the commas, but it is not prohibited to have a structure like that in CSV or text file that we usually use to represent datasets. So you can have the structure like this, so 2 commas put together, and that will also, if you uploaded your CSV to the pandas data frame, it will also be represented as not a number. So you will get almost the identical outcome. So if you have CSV without any values between commas, it will give identical outcome. I also said that maybe other person could put a question mark here, for example, like this, or I don't know, it can say, it can write no value, for example, and that is all a perfectly logical thing to do, and it is also valid. So for example, we can have multiple instances of missing values abbreviated differently. Our job is to basically all those instances represent in an identical way, and the best way to represent them is with a none, so with a not a number. We can do that just by mapping the values to none after. So we can have multiple nonce, so all those instances are nonce, or we can say during the uploading of our dataset. So I don't have a dataset prepared now, but I will just write you an example of the code. For example, let's say that I have some dataset.csv, and when I upload it to the Google Colab, I can immediately define what symbols represent missing values. So by stating the parameter NA values, NA values, so that are missing values, and defining it like putting all those symbols within the square brackets. For example, question mark, no, on, you can come up with anything. So if you put symbols here, all question marks or all words no, or anything else that you state within these square brackets will be treated as not a number. And then when you load these data sets, all question marks will be immediately shown as nones. All words no will be also shown as nones. So you can define all missing values as nones immediately when uploading the dataset, or you can do it later with whatever you prefer, or whatever is the case. So maybe you want to first upload the dataset and look at the dataset, and then after that see, I have some question mark, I have some blank values, and so on. I will load it again by stating that question mark means missing value and stating some similar things. Okay, so now we have a data set containing missing values that we'll use in the next code cells. So each column besides time step has some missing value. For example, temperature has 2 missing values, humidity also, and CO2, but they're on the different rows. So what should we do with this data set? So the first thing is to detect missing data. So we can detect all missing data from this data set just by looking at it, because it is a very small data set. But imagine that you have a data set which is often the case in the real world, that has hundreds or thousands of rows. So you can't detect all missing data set just by looking at the data set. You will have to do it programmatically. And Pandas offers you a way to do it just by calling the method isNa. So the method isNa is called on the data frame, and it will yield the following outcome. So for each code cell, it will return a true or false value. True value will be returned if the code cells contains not a number. If the code cells doesn't contain not a number, it contains some other value, so otherwise it will return false. This is still not a very pretty thing to look at it as a data scientist, because once again we can have hundreds or thousands of data sets, but this is the first step needed for some other function to do something with the missing values. Because if you have a method isNas to check if this data frame contains some missing values, this method can be used for other methods to determine which code cells are true in that manner. So which code cells do contain missing values. You can sum it up like this. So just add after the isNa function .sum function, or .sum method, that sums all those true values within each column. So you now get a aggregated data set that contains sum of missing value for each column. And now you get a better picture of how many missing values are there in the data set. So we can see that our column time step doesn't have any missing values, while other columns, temperature, humidity, and CO2, have each 2 missing values. So we now know the magnitude of the problem, how many missing values are there, and for what columns. We can represent it in some other way, for example, in a percentage or something like that. So we can count how many are rows in there in dataset, and then divide the sum of missing value with the len of the data frame to find out what is the percentage. For example, here we will have 1/4, so 2 of 8, so 25% of each column is missing, but this is not so important. So now I have code cell representing that in GitHub, but I think you get a sense of what how to collectively determine how many missing values are there in a dataset. Okay, so this is a summary of how to calculate and how to find out are there any missing values in a dataset. Okay. Once we determine, okay, there are missing values, the first logical or human thing to do is, let's see for which rows have missing values. So where are these problems? So we only want to see the rows containing not a number to determine why is there a missing value here. Maybe we can contact the person who sent us our dataset and ask them, okay, why is there a missing value for that particular column, for that particular row? Or we can come up with some conclusion by ourselves. So the first thing after determining that there are there are missing values in a dataset is to specifically look at the rows containing those missing values. So let's call those rows incomplete rows. So those are the rows that don't have every cell filled out. So we can make a data frame called incomplete rows that will only contain rows containing missing values. So one thing that we have to do is filter our data set, and we learned about filtering in previous workshop. So we have to write the name of the whole data frame, and then in the square brackets we have to write a condition for filtering. And we will use this method isNa that we learned in just now. So isNa determines is there any missing value. So we can call isNa on the data frame and say in this this particularly. So we can say, okay, if the data frame has any missing value, if there is any, and this x is equal to 1 parameter in the any method, means that we want to see if there is at least one true value for one column. So x is equal to 1 means that we want to look at our data set column by column. So that means we are going to through our data set column by column, and if there is any true value when we ask is there a missing value, that means that we want to keep that code cell, that we want to keep that row in our filtered data frame. Maybe I can explain it one more, but I will have to go to this code cell that I ran before. So just to remember you, so isNa returns a bunch of true and false values for each code cell. So we get a data frame of this identical structure as initial data frame, but this data frame contains only true or false values. So we filter this data frame to we use that data frame to make a condition just by going through the each column, and asking the data frame, do you have any true value? Do you have any true value? If that is the case, keep that row. So the row with index 2 should be kept because it has true value for the temperature, and also index 5, and also index 1, and also index 4, and the index 3 and index 6. So all those rows should be kept because they satisfy the condition. And I have to print the filtered data sets. So as I said, all the rows containing at least one missing value should now be in this filtered data frame that has only the rows containing any missing value, so at least one. We can play with this condition a little bit and state, okay, I only want rows that have 2 or more, or I don't know, 5 missing values. So we can sum those missing values, or let's say, for example, I want only data sets that contain 6 missing values, or something like that. But the most logical thing to do when you know that you have missing values and you don't know where are they, the first logical thing to do is to look at the data set. Look at each row containing at least one missing value. And now if you are expert in this domain, for example, you conducted the measurements by yourself, you know about the air quality field and so on, and you know, I know why is there no humidity value for this row. I forgot to measure it, or the device didn't work, but I know what the measure should be. You can go to your data frame and specifically put in this place some real value, if you know what the value should be. You can contact the expert in the field if you're just a data scientist and not in the domain, to fill out the values. But if you don't know what values should you put here, and you can contact anyone, or you contacted someone and they just said, okay, I conducted an experiment, I don't have every value, I don't know what to put there. Conclude by yourself, you're a data scientist, do something. Why should you do anything? Why shouldn't you just leave the dataset like this? Leaving missing values in the dataset can be a problem for future modeling procedures. But because if you want to derive some statistical measure, or even do something even more complex, for example, train some machine learning algorithm to predict something and so on, those algorithms don't like missing values, because in a programming sense, those values are not numbers. So their objects are called not a number, and you cannot do mathematical operations with those objects. So you can't, for example, calculate the difference between none and 15, or you can't I don't know, square it, or calculate square root or something like that. That is necessary for the operation of the machine learning algorithm. So if you leave the nonce or the missing values in your data frame, you have to be aware that maybe after in the later steps, after you do some modeling, you will get errors. So your models won't train. You will get some problems. So the best thing to do is to get rid of the missing values right away. And how to get rid of the missing values? The easiest way to do is just rid of all rows containing at least one missing values. Pandas offers very easy way to do that. The method is called drop_na. So the method drop_na just removes all the rows containing at least one missing values. So the resulting data frame doesn't contain any missing value. So it only contains rows that have every code cell filled out. That is the easiest way to do, and maybe not the best way to do. We can have a long discussion about this. Also, there are multiple discussions in the scientific community and among the practitioners. This is the easiest way to do, and a lot of people do it, myself included. But you should be aware of the drawbacks of this approach, and I think that drawbacks are pretty clear. You will get a very small data set after dropping after dropping rows containing some missing values. So, for example, here, after dropping missing values, we now have a data set containing only 2 rows, because this incomplete data set contained 6 rows. So you can do a basic math. Our initial data set had 8 rows. This incomplete data frame has 6 rows. So if we remove all those incomplete rows, we will now get a data set containing only 2 rows. And what can we do with the data set containing 2 rows? Well, nothing. So we came up with the data set that isn't really a data set, that we can do anything with it. So the drawback of dropping all missing data is that, so you get a lot smaller, a significantly smaller data set, and it is not for practical usage, but it can be in the situations where there are no lot rows with missing values, and you have a lot of rows. For example, let's say you have thousands and thousands of rows and maybe 10 rows with missing values. So the percentage of those incomplete rows is a lot smaller than here. Here is 25%. So if you get rid of all those rows, you don't miss out much. So maybe the easiest and most logical way to do that is to handle missing data in that situation is just to drop them. Okay, so that would be the first technique, to dropping all the missing data. So dropping all the rows containing missing data, it is done in situations when you have a lot of data and few missing values. Okay. You can also state by yourself, maybe I don't want to drop all the rows. Maybe I'm not so concerned if there are, for example, CO2 missing, but if the temperature value is missing, that I must for sure drop that value. So you can play it with also by the column. So you don't have to immediately drop the whole row if there are any missing value. You can say, I consider only temperature missing values as real missing values, and then say I will only drop those values. For example, I can show you. I can call drop na, and in the function call a subset parameter and state the value of that parameter. And now I get a subset of my dataset that only has rows that have some temperature value. So there are no rows with the temperature value missing, and you can join multiple columns. For example, let's say the CO2 is also important, so you can put CO2 here, but let's pretend that humidity values are not so important. For example, you know that you will model something and use only temperature and CO2, but you will not use humidity. So it would be a shame to, for example, remove these 2 rows because they have perfectly valid temperature and CO2 values. They don't have humidity values, but that doesn't matter. So you know that you won't use humidity in later modeling. But if you know that you will use humidity and humidity is important column to you, I advise you to either remove the rows with missing cumulative values, or we can now go to the techniques for filling the missing values. So the first thing that first type of techniques for handling the missing values is to just drop the missing values, and they are legitimate to use. They are often used, but you should be aware that you get a significantly smaller data set if there are a lot of missing values in your data set. So be careful with that. Okay, so that I would advise to drop missing values only if they represent a really small percentage of your dataset. What does it mean small? Well, I leave it up to you. It can vary from the domain to domain. For example, I worked with some financial data set a couple of years ago, and our team got a data set from some bank that contained, I don't know, hundreds of thousands of rows, and there were a lot of missing values, but we just dropped those values because the number of rows stayed in a range of about some 50 something thousand. So we didn't lose much, but someone would argue that we shouldn't do that. Maybe we should come up with some other techniques, but in that scenario, the dropping was the easiest and a solution, and it didn't influence the performance of machine learning methods that we later employed. But removing missing values is not often valid. Not a valid, is not a logical or I don't know, practical way to handle missing values. So alternative would be just to fill those missing values. The best way to fill those missing values is if you know what value should be there. But we discussed that. We said let's pretend that we already did our part on that. So we already asked the experts in the field and to whether they know some value to measure, but there is no response, so they don't know what value to put there. So we have to figure out by ourselves. So we as a data scientists don't often know the domain, so we can just use basic statistical measures. So for example, one logical technique is to fill all missing values within one column by some default value. For example, you can fill, for example, let's say that I will call our data frame field. I will call it field df, field data frame, by using initial data frame and just filling with some default value. For example, let's say for the beginning, let's use the easiest way to fill all values with a 0. And I can print the data frame. So now I have a data frame that doesn't have any missing values because we filled those missing values using 0. And now we shouldn't be concerned with the modeling of some machine learning algorithms because we won't get errors in the sense that not a number is present in a data frame, but maybe we won't get programmatic errors, but we can have some performance issues. Why? Because filling all the columns with just a value of 0 doesn't make sense every time. Okay, for a temperature, maybe 0 is a valid temperature. CO2 measure, I don't know, maybe it is. Humidity, it can be technically 0, but is that often a case? I would say no. But let's say that we have I don't know, some column that has a range of values outside of 0. Let's say, for example, a person's height. So you can't put a 0. So no one can be a 0 centimeters tall, or 0 kilograms, or zero, I don't know. Age can be technically 0, but if you're 1 year or older, you're not anymore 0. So putting 0 for each missing value solves the problem of having missing values, but it doesn't help you with the representation of those missing values, because now you don't have missing values, but you have some other problem, and that are illogical values, and then maybe can be a bigger problems. So you can fill the values for each column differently. You can put, for example, default value for temperature, default value for humidity, and default value for CO2. But saying default value, that means, for example, I can leave 0, or I can write, for example, 15 just for temperature. I can write some other value for humidity. I can write some other value for CO2. And then all instances of missing values for temperature and for humidity and for CO2 will be filled with that value. That is also a valid thing to do. So fill out the missing values with default values. And maybe that is sometimes the most practical way to do that. For example, if you know you're within this domain, and you know, I don't know, I don't have humidity measured, but I know that in most cases humidity is around 55%. So I will put 55. It won't influence the other modeling techniques so much. So I'm aware I don't have the real measurement, but I will purposely put 55. So you can just write for humidity. I'm sorry, I meant 55. So you can, in a Python dictionary, write like this. So if there is a missing humidity value, just put 55. If there is a temperature value missing, then put, I don't know, 18. And if there is CO2 value missing, let's put some other number, for example, 400. And I have extra parentheses here, okay? And now I get rid of all missing values, and now I have default values for each missing value. So if the temperature is missing, then the temperature is 18. If the humidity is missing, then the humidity is 55. And if CO2 is missing, then CO2 is 400. So you can deal with the missing values like this. You can put some logical default value to represent each missing values. So every time you don't have a measurements for that column, it will be that default value. You should put a lot of effort of determining that value, so it can so that it represents your column in the best possible way. But you can also count on statistics. So, for example, you can use statistics to determine what value should you use to replace the missing value. So you don't have to necessarily put some default value. You can use pandas to calculate some statistical measure. For example, you can calculate the mean value. So if you don't have, for example, temperature, you can calculate the average temperature and just put the average temperature instead of missing temperature. Or you can put, I don't know, a minimum temperature or maximum temperature or median value. So any statistical measure can be a perfectly valid choice to replace the missing value. And I will show you now how to do that. So we will do it for each data, each column separately. For example, let's put, first of all copy our data frame to leave it intact. So our initial data frame, and we will do all the operation of this filled data frame. And let's say that we want to fill the missing values in the temperature column by using the average or the mean value. So we will write like this: new temperature column will be equal to old temperature column filled with following values. So the new filled temperature column will be old column, where the missing values are filled with the mean of all existing temperature values. So this mean will ignore the non-values. It will just use valid values, and among those valid values, it will calculate the mean value, and that mean value will be used as an argument here in fill method to replace all missing values. And we can print out this filled df. And now we can see that the temperature here doesn't have any missing value, and all values are replaced, or missing values are replaced with the mean value. Maybe we can recognize what is that mean value, because I didn't print out the calculation here. Can maybe someone from the audience conclude what would be the mean here? Does anyone have any suggestion? Okay, Mia said 19.25. Let's check in the easiest way possible. We can scroll up to see what values were missing. So in what rows? So the value in a row with index 2 and with index 5, there were none values. So we can go down and see what is the value now. Here it is 19.25. So the answer is correct. So the average of those existing values is 19 point something, and then that average was used to fill the missing values. Okay, we can also put some other statistical measures, and I can show you. I will just copy this code cell 2 times, and instead of temperature, I will write humidity and CO2, and use some other statistical measures. For example, let's write median and let's say max. Just show what is possible. So now we dealt with all the missing values in the following manner. We replaced the missing values for the temperature with the mean value of the temperature of the existing temperature values. We replace the missing values for the humidity with the median, and we replace the missing CO2 values with the maximum CO2 values. So we can see, okay, we can scroll back up and see that, for example, for humidity, we missed values in the first index row with index 1 and the row with index 4 and 3 and 6 for CO2. So 1, 4, 3, 6. And we can scroll down now. And now when we filled, so we filled with the median value of 61 for humidity and with 450 for the 3 and 6. Okay, so this is one technique, so technique of filling missing values that is often used in practice. So you have a lot of missing values, you don't want to remove them, you also don't know what default value to put there. You can just use the existing data to tell your story about the data. So you calculate some statistical measure. And I don't want to go too much into statistics now because I presume that you have some basic statistical knowledge about statistics, so you know the difference between those measures. So you maybe know when it's more appropriate to use median value or mean value. I will just say if you have a lot of outliers, so extreme values, maybe it's safer to use median because those extreme values will move average value a lot. But if the distribution is not so skewed, it's perfectly safe to use average also. Maybe does have some sense to use mean or max value to fill the missing values. Maybe the situation is you want to be, for example, careful or think in a worst case scenario manner. For example, let's say that you have some data set describing the prices of houses in your neighborhood, and you don't know the price of some house, and you can the value is missing, and you don't want to overprice it, so you put just a minimum value for the house, and you are aware that probably that house is not of minimum value, but you should want to be careful. Okay, Maya wrote, what about interpolation? That is actually the next step. So that were basic techniques for filling out the data, but Pandas also offers some basic interpolation measurements, but you can do the interpolation by yourself. So we will only show those techniques that Pandas offers. So the easiest interpolation measures are forward fill and backward fill, where forward fill just copies the previous known value, while backward fill copies the next known value. So if you go through your data set just row by row, and then you find some missing value, the forward fill will fill those missing value with the previously known value from the data frame, while the backward would use the following value from the row that has a index a higher index to use that value to fill out the missing value. I can show you on an example. Let's say that we have this data frame with the missing values, so initial data set, and we can just forward fill all missing values. Easy, just create new data frame and call the FFIL method on the initial data frame, so forward fill method. And this will yield the following data frame. So you can notice that this data frame doesn't have any missing values, but let's see how those missing values were handled. So for example, let's see here, temperature. We can again scroll up and see in what row the temperature value was missing. So in a row with the index 2 and also with the index 5. Okay. And what are the values now here? Okay. So there is a value of 18.5 here and 19.3 here. Why? Because in previous rows, there were values 18.5 or 19.3. So the forward fill just copies the previous known value and fills that missing value. And everywhere where you can find multiple instances of the same row, for example, here and here, this is potentially a forward filling. If I just replaced one letter here and do the backward fill, we get a different outcome. Maybe I can. Okay, it's not necessary. I can rename those data frames, but it's not necessary. So I can just call the backward fill method and see the opposite result. So the temperature value that was missing in the row with the index 2 now doesn't have 18.5 value, it has 19 because it took from the next row. And also this row within index 5 has a value of 20.5. Okay, so those are basic interpolation measures that don't actually do any complex math to interpolate, just copies from the previous or the following row, and they are maybe also logical if you think about your measurements in a sense that the measurements that are close to each other in terms of row numbers maybe should share some similar values in some cases, in some domains. For example, if the time stamp is closer, so for example, the temperature didn't change a lot. So it would have more sense to use either the temperature from the previous hour or from the next hour than to use the temperature, I don't know, later in the day or earlier in the day. And that in those cases, those basic interpolation measures would have sense. Okay, but they have one drawback in a programmatic sense. They won't solve all missing values if you have if in some special cases. So the forward fill fills with the previous known value. But what if the first row already has a missing value? So forward fill wouldn't know what value to use, so it will leave not a number. And also backward fill, it fills the missing value with the next value. What if the last value, last row has a missing value? Then also the backward fill will leave not a number. So in those cases, you will be left with some of the missing values that you must handle in a different manner. So either put average or some statistical measure or some default value, or just remove those rows. And lastly, we can do really do the interpolation to estimate missing values from nearby observations. And the interpolation is just used like in statistical interpolation. So the missing values is the missing value for some column is modeled, but before is estimated using a model. Maybe I should be more clear. So it is estimated using a model. You can come up with a model by yourself. Maybe you can train some machine learning model, linear regression model, and so on. But if you just use Pandas default interpolation method, then it will use some basic regression model. So it will just use linear regression model to derive a model from the existing values and use that model to infer or to estimate the missing values. But I will show that you can play around with that. So I will just show first the basic method of interpolation. Okay, let's say that we want to interpolate the temperature, missing temperature values. We can do it like this. So the new column temperature will be old column temperature where the missing values are interpolated. So it is perfectly valid just to say interpolate and don't give much thought about what interpolation actually means. So I can print out my data frame. See, so I had this value and this value were missing, and the values were interpolated, so that they were estimated using a model used for interpolation purposes. So the linear regression model was trained for those measurements. So that model was used to estimate that particular value, so missing value. But you can also put some parameter values within the interpolate methods to explicitly state what kind of interpolation should you use. The default one is linear. So that means that the values are just equally spaced, so linear. But for example, you can use some other method. I'm looking at the Pandas documentation right now, and I will copy the link in the chat. But I will just mention a couple of famous methods. For example, you can use some polynomial function, for example, quadratic function or cubic function, or use some higher degree of polynomial where you will have to just write like this: method is equal to polynomial, and then state the degree of that polynomial. For example, the degree 5. So I will use a polynomial function with a degree of 5 to interpolate and those measurements. So, but I can also do some, I don't know, maybe more complex interpolation methods that are wrapped around some trigonometric functions. But I can also use some more straightforward interpolation methods, for example, index that will nearest that will just act as a backward and forward fill, or will just give the nearest value for that in terms of other features. For example, what if I have a temperature value missing, I can look at other values, and I can calculate the Euclidean distance between that row and all other rows. based on those other columns, and then I can find out yes, columns, and I can find out the row that is the closest to the row that that has missing value, and then just copy that value from that closest row. For example, let's say that this row doesn't have any temperature value, but it has a humidity of 63 and CO2 of 425. Let's say the closest row to that row is maybe the first one, because okay, the humidity difference is 2, but it's really close in CO2, while all others are maybe further from that row. So it would be logical to use the temperature of that row to fill out the missing temperature for that row, because all other measurements are the closest to that row. So you can use a bunch of interpolation techniques in pandas, and you don't have to write it by yourself. You can just call interpolate method and state in the parameters what interpolation methods should you use. Just before doing that, just go to the documentation, which I pasted here in the chat, and do your own research. So see what interpolation methods are present, what when should you use some of the proposed methods, and maybe that is the best way to fill the missing values. Okay, so to recap what to do with the missing values, first of all, you have to determine whether there are missing values in your data set, and you can do it by calling isNa method. So if it returns some true values, so there are missing values, but you can aggregate it using a sum method, so it will yield an aggregated outcome of all missing values. So you will now know you have some missing values in that column. There are so and so many missing values in that column, so and so and so on. And after that, maybe the most natural thing to do is just look at the rows that have any missing values, so you can filter the data set by using that isNa and any methods to derive a condition to look just only the rows containing missing values, and then decide what to do with them. If you know what value should you use to replace the missing value, great. It's maybe the optimal thing to do in that scenario. So you know that humidity should be that, you put that value. But if you don't know what to do, the first group of techniques will tell you remove the missing value. The second group of techniques will tell you fill the missing value. Either one is perfectly fine. You should do either one or two. You shouldn't leave your data set filled with missing values. If you have a lot of values and not so many missing values, maybe it's easiest to just get rid of those rows. So if you have, I don't know, 1% of your data has a missing value, so you can remove those 1% of data. If the percentage is higher, or you can consider even 1% higher, you don't want to remove those values, so you will have to fill those missing values with some value. Okay, you can come up with the default values. You can calculate some representative values using statistical measures. You can interpolate. Easiest way to interpolate is just by looking at previous or next rows, or you can use some complex interpolation method from pandas. Look at the documentation and select some appropriate measures. There are a bunch of measures, so I presume some of those measures will do. And maybe the last thing to do if you're not satisfied with any of those methods is to come up with your own solution to fill out the missing values, but with your own, I don't know, interpolation method and something like that. But that is out of the scope for this workshop. So I plan to also talk about the outliers today, but I think that for today's workshop, this Jupyter notebook with the topic of handling missing data is enough, because we spent more than an hour today, and I think then we can leave the outliers and also the next topic time series for the next workshop. As in the previous workshop, I put a small hands-on practice task at the end of the notebook. So if you downloaded the notebook from the GitHub, you have an empty code cell that is ready for you to fill it out. So you can try the different techniques that we discussed today and see how the dataset changes when you apply these techniques. And if you have any question regarding this task, or if you have any issues, feel free to contact me via email, and I will write my email to in chat here. But I also put the solution of that task here. So maybe you can first look at the solution. If you're not sure why solution like that, you can contact me. Okay, are there any questions regarding that today's workshop? No, maybe okay, one question is how to handle missing values when the process changes rapidly, especially in a time series dataset where a large chunk of data is missing. So my plan is to talk about time series in one more workshop, where when dealing with time series, we have to be quick. We have to respond promptly, but the handling of the missing data doesn't change much. So either we will remove the value. So for example, let's say in real time we are collecting the data where the time frequency of the time series is really fast. So we have to use specialized hardware, of course, to work promptly. But techniques for dealing with those missing values are not so much different from techniques that we described today. So either you will drop the value that is missing, or you will replace it with some default value, or you will calculate the mean or some other statistical measure. And also great thing to do in parallel when working with time series is to always have those statistical measures prepared. So if you have some missing value, maybe the great thing to have is right away already calculated mean from previous values. So just use that mean to replace a new missing value. So you don't spend so much time on calculating a new mean. Okay.